In this video, we are going to talk more about piecewise functions, how to graph them, how to write the equation of piecewise functions, and how to look at them in context. So for this first equation, we are going to graph the piecewise function. So for the first equation, it's an absolute value equation, and it's true between negative infinity and 2. So an absolute value equation is a v-shaped function, and this is going to be a one-to-one function. So if I start at 0, 0, it's going to go up 1 over 1 on each side with an open circle at 2. And it goes from negative infinity to 2. So it's going to come in and then stop at 2 with an open circle. This function 5 is a horizontal line at 5. And it's only going to be true between 2 and 3, which are both included. So at 5, 2 to 3. Then this last function, negative x squared from 3 to infinity. Well, x squared is a parabola, but it's negative x squared, so it's going to be pointing down. So if I think about from 3 to infinity, negative 3x squared is negative 9, because remember you're doing negative 3 squared, so negative 9. So that's going to be about here, and it's not included, and we know it'd be a parabola going down. Yeah. All right, let's answer some questions. The domain. Well, it looks like the domain is continuous from negative infinity to infinity. And if you can see, my functions are going opposite directions. So my blue function has a max at infinity and a min at 0. Then there's a gap all the way down here till I get to negative 9. And so this is negative infinity to negative 9. So negative infinity to negative 9. And then we start up again at 0. And we're going to go to infinity. At negative 1, you could either use your graph or use the equation, but negative 1 would go into the absolute value, so negative 1 would be 1. 2.5 would go into between 2 and 3, so the answer would just be 5. 7 would go into the negative x squared, so again, that would be negative 7 squared, so it would be negative 49. All right, let's look at our real-world example. A museum charges $5 per person for a guided tour with a group of 1 to 9 people, or a fixed $50 fee. For a group of 10 people or more, write a function relationship for n and the cost of c. So essentially I need to write a piecewise function. So $5 per person for a guided tour from 1 to 9 people. So if it's 1 person or if it's 9 people, and they want me to use n, not x. Instead of saying 1 to 9 with the equals, we could have also said 0 to 10 with the not equals. Either one of those would be acceptable. And then if it's $5 a person, it'd be 5 times n. Now they're saying it'd be a $50 fixed fee, meaning $50 no matter what, if n is greater than or equal to 10. All right, it does say it wants us to sketch a little bit graph, so I'm going to sketch a graph from 0 to 10, and then 10, 20, 30, 40, 50. This would be number of people, and this would be the cost. So from 0 to 10 would cost $50. After that, it stays constant at $50. Keeping in mind that really this is a constant rate and that there are no half people, so it would be more like a step function than a linear function. So we're going to kind of try to show that here. But then after 50 people, after 10 people after $50, it would just be a constant rate no matter how many people you added after that. All right, now in the back, we are going to write the equation of each piecewise. So for every piece of the function, we need to write part of the equation for that. So the function in terms of x. All right, so I'm going to write from left to right. So if I look at this first piece right here, that piece is going from 1, 2, 3, 4, 5, 6, 7, 8. So -8 to -2. And so we could either use inequalities, or if you wanted to use interval notation, we could do that as well. So what is the equation of this line? Well, I'm going to keep tracing the line back to the axis so I can see it would have a y-intercept of 8, and it looks like it has a slope of 1/2. So it'd be 1/2 x plus, 6. Sorry, not 8, 6. All right, look at the next piece, which is this little squiggly piece here. That is actually a cubic function, so x to the third, and that is true from this x value to this x value, but not included. So it'd be -2 is bigger than x, which is less than 1. This next little piece is at 1, 2, 3, 4, 5. It's just a constant piece, so it'll be 5. And that is true from 1 included to 3 not included. So let me quickly, if you want to write these with the interval notation, you could also write it like this. All right, and the last piece right here, again, to write this equation, I want to trace it back. Oh, it's actually going to start at the origin, and looks like it has a -1 slope, so it's the function of -x. And this is going to be true from 3 to infinity, so I'm just going to say x is greater than or equal to 3. Or if you were writing with interval notation, you would say 3 to infinity. All right, let's look at this next one. So I'm going to look at this first piece. It looks like it's linear, so I'm going to trace it back to see where it started. So it looks like it starts at, actually, it looks like it has a 3 slope, so 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Right, up 3 over 1, up 3 over 1, yeah. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Looks like it starts at 10 on the y-axis, and like I said, it has a slope of +3. So it'd be 3x plus, maybe it's 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11. But it's only true in the highlighted part, which is 1, 2, 3, -4 included, 5, 6, 7. -7 not included. Oh, no, but it only goes to 6. Sorry, guys. -6. And again, if you wanted to write it with the interval notation rather than inequality notation, you could write it like this. All right, our second one, this guy is a V, so that is an absolute value starting at 0, and it's true from -4 not included to 2 also not included. Then this last section is a horizontal line at 4. from 2 included to 3, 4, 6 not included. All right, let's look at this last graph. All right, so if I look at this first piece, it looks like it's linear, so I'm going to it looks like it has a slope of 2, -2, so I'm going to trace that down. So it starts at -4, has a slope of -2, and it's true from -infinity to -2, or if you're writing with absolute or with inequalities, you would say it's less than or equal to -2. This one I'll write with interval notation first. This middle one is a absolute value, so it's an x squared that's actually shifted down 2, so it'd be x squared minus 2. And this is true from -2 to 1, not included. So x would be between -2 and 1. This last piece is a linear, but at y equals 2, and it's true from from 1 included to infinity, which would be x is greater than or equal to